You know, AI can do some absolutely incredible things, but it's got this weird and frustrating habit. It lies. Sometimes it's just small errors, but other times they're complete fabrications. In this explainer, we're going to look at why this happens and explore some of the really clever engineering solutions being built to tame these AI hallucinations.
So let's start with the big picture. What's the ultimate goal here? Well, the promise of AI is nothing short of revolutionary. You've got companies like xAI aiming to use this tech to fundamentally accelerate our understanding of the universe itself.
Of course, a vision that grand needs an equally powerful foundation to stand on, and that's where the cloud comes in. The whole goal here is to build infrastructure that isn't just powerful, but also incredibly reliable and stable, the bedrock on which all these new AI tools are going to be built.
So you have this powerful combination, right? Immense computing power from the cloud and just vast amounts of data. The dream is simple. Feed all that data into the machine and get back brilliant, actionable insights. But there's a fundamental problem lurking just beneath the surface.
And here's the twist. For all their power, for all their potential, these incredibly complex systems have this fundamental and, let's be honest, often super frustrating flaw.
It's a phenomenon they call hallucination. This is when an AI generates an answer that sounds plausible, confident, and really well-structured, but it's just plain wrong. It might be a small error, or it could be a completely fabricated story.
And look, this isn't just some theoretical problem that researchers talk about in a lab. It has real-world consequences for people using these tools every single day. Just take this user of Google's Notebook LM, who found that a tool that was working perfectly one day suddenly became unreliable the next, refusing to answer questions it had answered before. This kind of unpredictability is a huge issue.
So researchers have kind of broken this down into two main types. First, you have intrinsic hallucination. You can think of this as the AI contradicting itself. It's given a document and then says something that goes directly against what's right there on the page. Then you have extrinsic hallucination, which is when the AI just starts making things up, pulling facts out of thin air that weren't in the original information at all.
And here's where it gets really important. This erratic behavior isn't always seen by users as just a random error. Some people start to suspect it's a deliberate feature, maybe a form of censorship or an overzealous safety filter. This is where a technical problem starts to bleed into a much bigger debate about trust, control, and freedom of information.
So this raises a massive engineering challenge, right? How do you fix a system that can lie so convincingly, especially when the fixes themselves might be seen as a form of censorship?
Well, the key architectural shift is all about moving away from relying only on the vast but static information the AI memorized during its training. The idea instead is to give it access to a live, trusted source of facts in real time.
The leading technique for this is called Retrieval-Augmented Generation, or just RAG for short. Here's how it works. First, you ask a question, but, and this is the crucial part, before the AI even tries to answer, the system does something critical. It retrieves relevant documents from a trusted knowledge base. Only then does the AI use those specific factual documents to construct its answer.
This analogy just brilliantly illustrates the difference. A standard large language model is like a student taking a closed book exam. It can only rely on what it has memorized. If it's unsure, it might just guess. A RAG-powered system, on the other hand, is like giving that student an open book exam. It can look up the facts before it answers, grounding its response in verifiable information.
And the research is totally clear on this. Studies confirm that by forcing the AI to ground its answers in retrieved data, you can dramatically reduce the rate of hallucinations. But you have to notice that crucial little caveat on the research, as long as a correct reference can be found. RAG is powerful, for sure, but it's not magic. It's only as good as the information it has access to. So, RAG is an incredibly powerful tool. But building true trust in AI isn't about finding one single solution. It's about applying solid, time-tested engineering principles to this new technology.
This is where it gets really interesting, because the cutting edge of AI development is meeting the foundational principles of building any large-scale, reliable system.
Frameworks like Google's well-architected framework provide a blueprint. Now, these pillars might seem abstract, but for AI, they are absolutely critical. Reliability means the AI is always available and doesn't crash mid-answer. Security means its knowledge base can't be poisoned with false data. Performance means it can find the facts and generate an accurate answer quickly. It's all about making these AI systems as robust and dependable as any other critical piece of our digital infrastructure.
And this brings us right back to that central tension. As one user astutely analyzed, the very techniques used to make AI safer, like filtering out unsafe data during training, can have a side effect. The model doesn't just refuse to answer, it may fundamentally lack the knowledge to even engage with certain topics, making it feel more restrictive.
And this leaves us with a final and really crucial thought. We can engineer AI to be more factually reliable, but in the process of making it safe, we are embedding a specific set of values into its very architecture. So the real question isn't just how we stop AI from hallucinating, but whose version of reality we choose to ground it in. The technical challenge of fixing the glitch is one thing, the human challenge of defining the truth is another entirely.